Good evening, everyone. So, this is your task 5 of data analysis and data science. Okay, so for this, we have taken up a project named heart disease analysis. So, basically, we will analyze our heart disease data set that is present in your Google Drive link. Okay, and this project you can also add in your resume, it depends on you. And we will apply all the skills in this project that we have learned so far. Okay, yes, so here's the code, here's the project. So first task of you is to import all the necessary libraries that we need into your Jupyter notebook. So first library is NumPy. This is used for numeric data set. Second, Panda, which is a basic library in which there are many inbuilt basic inbuilt functions. Third is matplotlib.pyplot. This library is used for visualization. Then comes the Seaborn library, which is used for the advanced visualization. Then comes the %matplotlib inline. So basically this library is a command. It allows you to display plots and visualization directly within the notebook interface rather than in a separate window. Okay, then your second task is to import your data set. So you know how to import your data set. Now we have to use some of the functions for analyzing our data set. Okay, so here we are using the df.head function. So you know by default head function will give you top 5 rows of your data set. So here's the top 5 rows of your data set, and these are the column names of our data set, which is age, sex, CP, cholesterol, etc. Okay, and then we have used df.tail function. So basically tail function will give you the bottom 5 rows of your data set. Okay, so here's the top 5 bottom 5 rows of your data set. Okay, now we'll take a look at the column names. These are the column name. By using the columns dot values you can take a look at the column names. Now our next task is to check for the null values. Okay, so by using the function is na.sum function we will check for null values, and here the answer is 0 for each column, for every column. So there are no null values present in our data set, so there is no need for handling our null values. Okay, now we'll see the concise summary of our data set by using the info function. So it will tell you how many non-null counts are there and what is the data type of each column in our data set. So 1025 are non-null counts and data type is integer, all integer except the alt pick column. Okay, now we have to plot the histogram of all numeric values of all the columns. Okay, so you know how to plot the histogram by using the hist function. Then you have to mention the bins, which is 50 here. So what is bin? Basically bin refers to the interval or ranges. These are the interval or ranges into which data is divided for analysis or visualization. Okay, so if we do here, if we change here 50 to 100, now you'll see what is bin. Basically, see, now interval or ranges is increased. Okay, so this is your bins part. Okay, now here's the grid. So what is grid? Typically, basically grid refers to a set of evenly spaced lines or dots that form a network of reference point on a graph or plot. Okay, means the grid helps in visually aligning and interpreting data points. Okay, making it easier to read. If you don't want grid, you can use here false. If you want grid, then you can use here true. And now they will show you what is grid. Basically, see, this is your grid, a set of evenly spaced line in the background. Okay, so if you want grid, then you can use here true, otherwise you can use here false. Okay, and last, this is your figure size. I'm changing it, both the things again. Then last is your figure size. Figure size is for setting the figure. Okay, which is length and breadth of your figure. Okay, So here this is how you have to plot the histogram of all numeric values. These are the all numeric value histogram. Now we'll generate the descriptive statistics by using the describe function. This is your descriptive statistics. Okay, so till here we have analyzed our data set, and we have analyzed what are the column names and the values containing in each column, okay, by using the histogram. Now we have to make up a questions, a set of questions. So here I have taken the 4 questions. You have to add these 4 questions into your task, plus you have to add 3 more questions by yourself. Okay, means minimum 7 questions you have to take by your, you have to do in your task, and maximum 10 till 10 you can go. So these are the 4 questions. So how to do is, you have to prepare a set of questions, then you have to solve each question by using the appropriate function, and then you have to visualize each answer, okay, each question answer. So here's the first question. Now we'll solve the first question, which is how many people have heart disease and how many people doesn't have heart disease. So for getting the value of this question, we have to use target column, in which the target column contains only 2 kinds of value, which is 1 and 0. So 1 represents the people having heart disease and 0 represents the people having no heart disease. So by using the target column dot value underscore count function, you can see the result, which says 526 people are having heart disease and 499 people are having no heart disease, and it is of like basically this value come from our given data set. Okay, now we'll plot a bar chart for the same answer. We have to use this variable, this answer dot plot, and here kind is bar, and here we have fixed the color orchid and salmon. Okay, and title is heart disease values, and x label, you know all the syntaxes are same, how to plot the x label, how to set the x label, y label, and title. So this is our bar chart for showing heart disease values. Okay, here 1 represents the people having heart disease and 0 represents the people having no heart disease. Okay, now comes the plotting a pie chart. So we'll plot a pie chart for the same answer. Here kind is now pi and fixed size is 8,6. So you can also change the fixed size if you wanted large. Okay, so this is your figure size 12 comma, this means your length and breadth is increased. So this is how, by using the fixed size function, you can set the size of your graphs. Okay, and this is your legend, which is disease and no disease. So here blue color represents the people having heart disease and orange color represents the people having no heart disease. Okay, now let's check how many male and female are in the data set. Okay, so for this we have to use sex column. So in sex column, 0 represents the female and 1 represents the male. Okay, so in sex column, 0 represents female and 1 represent male. So to check how many male and female are in the data set, we have to use sex column, sex dot value underscore count function. It will give you the answer. See here 1 represents male, so 713 are number of males present in our data set and 312 are females present in our data set. Okay, now we'll plot a pie chart for the same. Here kind is pi, rest all other syntaxes are same. So this is your male female ratio. Here blue color represents the male ratio and orange color represents the female ratio. Okay, so from this pie chart, it is very clear that male ratio is double than the number of the female. Okay, so now let's find the answer of our second question, which is people of which sex has most heart disease. Okay, so for this we are plotting the cross tab between the target column and sex column. Okay, so what is cross tab function? Basically cross tab creates a cross tabulation table that display the frequency or a count of occurrences for each combination of category from the variables. Okay, so basically this table helps in understanding the distribution and relationship between variables and making it easier to identify pattern and insights in the data. So for this, here we are plotting the cross tabulation between the target and sex column. So this is your cross tabulation. Here it says this represents male, this represents female, and this represents no heart disease, this represents having heart disease. Okay. Now we'll plot the count plot for the same. Okay. For the same answer, here X we have taken target, data is DF, and hue is sex. Okay. So title and X label, this is your title, which is heart disease frequency for sex, and X label is this. Okay, so from this count plot, we have analyzed that number of male is more than double in our data set than female. Obviously, then more than 45% male has heart disease. Okay, 45% male has heart disease and 75% female has heart disease. Okay. Now let's move to the question 3, which is people of which sex has which type of chest pain most. So for this we are going to use CP column, and here's the 4 kind of chest pain, which is 0, 1, 2, 3, and these are the number of people having these kinds of chest pain. Okay. Now we'll plot a bar chart for the same. Here kindness bar, color we have fixed salmon, light sky blue, spring green, and fourth is your khaki. So by assigning the color, you can also make it a visually appealing for the user. Okay. So here title is chest pain type versus count. So this is your count. Okay. And now we'll plot the cross tabulation between the sex and CP column, because we want to find people of which sex has which type of chest pain most. Okay. So here's the cross tabulation between the sex and CP column. Okay. And here's the visualization. Here is the bar plot for the same answer. Here we have fixed the color, which is first is coral, second is light sky blue, third is plum, fourth is khaki. Okay, and rest all the syntaxes are same. So this is your type of chest pain for sex bar plot. Okay, so from this we have analyzed that most of male has type 0 chest pain and least of male has type 4 pain. In case of female, in case of uh, in case of female, this is for female, this is for male. In case of female, type 0 and type 2 percentage is almost same. Okay. Now question 4, which is people with chest pain are most prone to have heart disease. So for this we are plotting the cross tabulation between CP and target column, and here's the count plot for the same answer. Here X is CP, data is DF, U is target. Okay. So here's your result, which is the count plot. Okay. So here from the count plot, it is clear that most of people who has type 0 chest pain has less chance of heart disease, and we see the opposite for the other types. Okay. Now let's take a look at our age column. Okay, so we have to create a distribution plot with a normal distribution curve. So what is distribution plot? Basically it is a Seaborn library. Okay, so it display the distribution of a single numerical variable. Okay, it combines a histogram with a kernel density estimate plot. It provide a comprehensive view of the data distribution. Okay, so here is the for you for plotting the distribution plot, you have to use this plot function. Here X is age, data is df, bins is 30. Bins means interval or ranges, and here KD is 2. KD is kernel density estimate. Okay, here KD is 2. So if you use here KD equal false, yes, now you'll see the result. Here KD is false. Okay, means that kernel density estimate curve is not here. Okay, so that is for making a comprehensive view. Okay, so from this plot, it is clear that 58 to 59-year-old people are most in the data set. 58 to 59 people are most in the data set. Now let's plot another distribution plot for maximum heart rate. So for maximum heart rate, we have to take column name, which is thalage. Okay, so here X is thalage, data is DF, bin is 30, KD is 2, means that kernel density estimate curve is 2, and your color is chocolate. So you can also set the color. Okay, so here color is chocolate. From this plot we get a clear overview about the maximum heart rate represented by thalage. Okay, so yes, this is how you have to do your task 5 project. So I'll give you a brief once again. You have to first import all the necessary libraries, then you have to load a CSV file, then you have to use some of the functions for analyzing your variables, then you have to check for the null values, then you have to make the concise summary of your data set, and you have to plot histogram of all numeric values. This is your descriptive statistics. Then you have to make a set of questions here. These are 4 questions that you have to add in your task, plus 3 more questions you have to take by yourself, minimum 7 and maximum till 10 you can go. Then you have to solve each question by using the appropriate function, and then you have to plot a visualization for each answer. Whether it depends on you what kind of chart and plots you want to plot, whether the bar chart, pie chart, test plot, count plot, etc. Okay, so you have to solve each question by using appropriate functions, and then you have to visualize it. Basically you have to analyze your data set. Okay, so yes, this was all your task 5. I hope this is clear. If